Okay, so, considering this, we can do our little rudimentary example just so you can kind of maybe see the workflow of what you want to do with these things. So you have to get dimensions of your piping system, usually going to be given to you, or sometimes you'll have to figure out what a diameter is, which I went over. But the easiest situation is if you're given the pipe dimensions, and then you just ask to, what is the head loss? So, I'm going to look at this equation. You can just kind of read it left to right. The first expression is F. So we need to find the Darcy friction factors for this piping system. So say we have a flow rate in there as well. I'm doing this example live, by the way, so I won't put numbers to it. So for your velocity, it's not that bad because you'll need to have, take your flow rate that you're given and divide it by the area, whatever numbers they are. Make sure the units are correct. More explicitly, since this is just area, you'll have this be pi d squared, 4 goes up top. So this helps you get a velocity. Now, what do you do to get friction factors? You need to calculate a Reynolds number, because these friction factors are functions of Reynolds numbers, and they're functions of these roughness value heights. So then you get the Reynolds number, rho, v, d, whatever it turns out to be. Now, let's say it turns out to be turbulent. So that would mean that this value ends up being greater than 2,000. So that means it's a turbulent flow. So if it's turbulent, look up look up the roughness height of the pipe material. So this wall has some roughness height. Okay, now you're going to take this, divide it by this, and now you have this non-dimensional roughness ratio. Then you just want to see if it's hydraulically smooth or fully rough. Let's say it's smooth. Though. So then you would if you go back, there was that big formula where I could just plug in the Reynolds and I could plug in this. It was an approximate one, and then you can just calculate what this F is. So now we're at the stage that we have our friction factor. What's the equation tell us? And we're done. Remember, we already had to calculate this velocity value to get the Reynolds number. That helped us get this friction factor. These quantities are given to us, so then you can just calculate what the head loss is for a long straight section of pipe.